So yeah, my talk is about GraphQL and Prisma, and I know that's basically the last session for all of you today. I won't be mad if I see people fall asleep, but hopefully the content of the talk is exciting enough to keep you all awake. So my name is Nikolas Burk. I'm based here in Berlin. I work at a startup called Prisma, and we're building all sorts of tools in the GraphQL and database space. You can find me on GitHub and on Twitter as @NikolasBurk. The agenda for the talk today is threefold. So I'm going to start with a GraphQL introduction so that we're all on the same page about the major concepts of GraphQL. Then I want to dive a bit deeper and really want you to understand how GraphQL servers actually work under the hood. And then I want you to understand a bit better how you can build GraphQL servers with Prisma. And to get a bit of a feeling for the audience, I would like to know, just by show of hands, who of you is a front-end developer? Okay, few front-end developers. Who is a back-end developer? All right, I guess, who is a full-stack developer? Okay, a few of those people also raising their hands. On the back-end side, who of you is using Java as their primary language? Okay, who's using JavaScript and Node and TypeScript maybe? Also, a few people. Who is using a language like Go or Python or Scala maybe, something like that? Okay, awesome. Okay, so I also will do a fair bit amount of live coding actually, and that will all be in JavaScript, but I think that the code should be simple enough for everybody to follow. So let's start with the GraphQL introduction and the big question, what's GraphQL? So very briefly stated, it is a new API standard that was developed by Facebook in 2015. And it basically is a specification for a type system and for a query language. So it's just a long document actually that you can read online where it's precisely described how the type system of GraphQL works and how the corresponding query language actually works. And there are three core primitives that we're going to learn about and that are called query, mutation, and subscription. Queries are the way in GraphQL how you can read data from an API, and mutations are the way how you can cause some sort of side effect on the backend. And then we also have subscriptions, which are for real-time operations, but we won't really cover them in this talk. Why would you want to use GraphQL? So first and foremost, it has a strongly typed schema for your API, and that's my personal favorite. Maybe you've worked with REST APIs in the past, and you've used a tool like Swagger or what's called today, I think, OpenAPI, and there you get kind of similar benefits, but GraphQL has its own schema definition language that we'll also see later on, which you use to declare the schema. And that strongly typed schema has a couple of advantages, like auto-generated documentation for your API that you will always get out of the box if you're using GraphQL. So you're never left questioning the API operations and the kind of variables you need to provide for these API operations and what the return data structures actually look like. Then one big advantage, and that's the advantage that usually gets the front-end developers hooked, is that you can query exactly the data that you need in a single request. So if we have a situation on the front end where we need to implement a view where we would hit three different REST endpoints to get the data that we need, in that situation, we have to make 3 network requests to get the data, and then locally on the front end, we have to actually put the data into cache and then eventually display it on the UI. With GraphQL, you can query exactly the data that you need in a single request by submitting what's called a GraphQL query to the server, and that query resolves all the requirements that you have on the front end, and then you can display the data in the UI. And there's also a really rich ecosystem and a great community around GraphQL, despite the fact that it's really only 3 years old. So what does a GraphQL query now actually look like? So here on the left, we have a front-end client, and on the back end, we have the server. And this is what a GraphQL query actually looks like. So it has a number of fields, and these fields describe the data requirements of the front end. So translating this into the data requirements that are expressed by this query are basically we're asking for a user with a particular ID, but we only want to retrieve the name of the user And then there also is a relation from a user type to a post type, and then we're asking for all the posts of that particular user, but only the titles of the top. So we can really, on a fine-grained level, describe the data that we actually want to receive from the backend, rather than being tied to fixed REST endpoints. And here is what a potential response might look like. So what's really important to understand is that the GraphQL query dictates the shape of the response that's going to be returned by the server. So the shape of the query is identical to the response that we're receiving from the server. So one way of looking at a GraphQL query is actually as like an empty JSON object that you send over to the server, where you only have the keys of the fields that you're interested in, but not the values, and then just let the server fill in the values for you. And on the previous slides, I've mentioned 3 reasons why you would want to use GraphQL. In this article, you actually have 5 reasons. And then if you want to learn more and get a more thorough introduction, I would recommend to you the howtographql.com website, where there's a really thorough introduction to the entire topic. All right, so that brings me to the first part of the demo. I have prepared a little GraphQL server for you, and I want to show you what GraphQL queries and mutations actually look like in practice. So here I have a GraphQL server currently, which is running on my local machine. And this entire thing that you see here is called a GraphQL Playground. GraphQL Playgrounds you can imagine as being somewhat like a GraphQL IDE or a query editor. If you've worked with REST, you can compare it with a tool like Postman. It basically allows you to send requests to a GraphQL API and see the response immediately. And what's really cool about GraphQL, and I've mentioned this before already, is that with every GraphQL API, you always get this auto-generated API documentation. So here I can click on the schema button, and I can see exactly what kind of operations are available at that API. So I don't need to guess what kind of operations I can now send, but instead I can just look them up. So here on the right side, it says that we have 1 query and 3 mutations that we can currently send. So let's try them out. Here I'll start with the post query and just ask for the posts that are available. And here is another really cool feature of the GraphQL Playground, which is also due to, or thanks to the GraphQL schema, is that the GraphQL Playground also has an auto-completion feature, which is also built in. So I can send this query, and it returns all the posts that the GraphQL server currently has available. So let's go ahead and try a mutation. So I have the create draft mutation available, and I'll just create a post and draft with some random data for now. Ask for the ID in return, and I'll send this a couple of times. If I now go back to the post query and send that again, then the new posts that I just created as draft, so draft basically means that the published field is set to false. These new drafts show up in the response of the post query. So I can now go ahead and publish a draft by using the publish mutation. And if I go back to the post query, we'll see that now the GraphQL server did what we expected. It set the publish field to true. Then we also can use the delete post mutation to delete a post. I'll just delete the very first one. And going back to the post query, we see that the first post disappeared. All right. So much for how a GraphQL, or how you can use GraphQL in terms of sending queries and mutations, and what a couple of these really cool tools that you get for free when you're working with GraphQL actually look like. So let's move on to the next part and understand how GraphQL servers are implemented under the hood. So one thing up front, you can build a GraphQL server in your favorite programming language. So it's not bound to a particular language, because GraphQL itself really is only a specification. So it's just the abstract specification of what a GraphQL server actually looks like, how it needs to behave, and how it needs to resolve its queries. And no matter which programming language you're using, you'll always find these three parts for your GraphQL server. So first, you have the API definition, which is the GraphQL schema. Then you have the concrete implementation, which are called resolver functions. And then you have the setup for this. So usually you'll probably want to build your HTTP server in a way that it speaks HTTP. So that's like the most common transport protocol that you're using for GraphQL servers today. But potentially you could also use another transport layer. So you're not bound to HTTP by the specification, but most GraphQL libraries that you'll find today are using HTTP. So let's take a look at each of these three parts in more detail. So first, the GraphQL schema. The GraphQL schema is strongly typed and written in what's called the schema definition language. So it has its own language to describe what a schema actually looks like. And it defines the API capabilities and can be seen as the contract for client-server communication. So whenever a client has access to some GraphQL API, it can read the schema and it can infer all the operations that are possible in the API. And there are three special root types that map to the core primitives that are provided by GraphQL that are called query, mutation, and subscription. And these root types, they define the entry points for all our operations. And we'll see a bit later with a practical example what that means. And here we go. So on the left, you have probably the most simple GraphQL schema that you could imagine for a simple Hello World app. So this would be stored on the server side somewhere, and the server would implement this GraphQL schema. If a server implements this schema, what does this tell me as somebody who has access to this schema, what kind of queries I can send? In this particular case, I can only send one query, and that also looks very simple, just like this, and only uses the hello root field from the query type. So this is the query that a client could send to the server, and then it could get a response that looks like this. Just a simple, just a simple object that only has one field, hello, with some string inside of it. And again, the shape of the query dictates the shape of the shape of the response. In this case, it's super simple because we only have one field in the query. We also only have one field in the response object. Here is a slightly more useful example. So here we are using the GraphQL schema definition language to define CRUD operations for a user type. So we first define a user that has an ID and a name, and then the query on mutation types, they define the actual entry points for our API, so they define the actual operations. And in this case, we have one operation that lets us ask for one individual user for a list of users, so these are the read operations. And then on the mutation type, we have the create user, update user, and delete user mutations that allow us to perform the create, update, and delete operations for the user. If we only look at the user field right here, what does this tell me as the client of the API about what a GraphQL query looks like that I can send to the query, to the server? It basically tells me that I can send a query that starts with the user field and takes an ID parameter like this, but then because the return value or the type of the user field on query is itself user, I can now nest more fields inside the query. And in this case, I'm just interested in the name of the user with that particular ID, and the server, again, might respond with some data that looks like this. So this, again, is the same shape as the query. The JSON object looks the same as the GraphQL query that was submitted. Let's now talk about resolver functions, because resolver functions are the way how the GraphQL server is actually implemented. So what happens when a GraphQL query arrives at the server and the data actually needs to be fetched? So this is the task or the responsibility of resolver functions. They provide the concrete implementation of the API. And you basically have one resolver function per field in the STL schema. And this means that the query execution process basically just becomes a matter of invoking all the resolver functions for the fields that are contained in the incoming query. And actually, GraphQL is sometimes compared to remote procedure style systems, which is a technology that basically which lets you invoke a function on your local machine, but the execution of the function is happening on a remote machine. And sometimes GraphQL is compared to these kinds of systems because if you look at it that way, that the GraphQL query just like contains all the function calls that are supposed to happen on the back end, then it effectively is some sort of remote procedural call as well. Let's take a look at an example again. So here we have our very simple hello world schema again. And this is what a corresponding resolver function would look like in JavaScript. So we define an object that is called resolvers, and that resolvers object has a field that is called query, which again is an object that has a field that's called hello, and that now is a function that returns just a hello world string. What's important about this setup is that the fields in the resolvers object have the same names as the fields inside your GraphQL schema. So it's important to write query in exactly the same way that you wrote it in the GraphQL schema, as well as the hello function also needs to be written in the same way as you have it in your GraphQL in your schema. What would it look like for the CRUD user type example? So again, we have the same situation that we have a resolvers object, and then again we follow the same structure, and for each field in the GraphQL schema, we have one resolver function on the right. So we have a resolver for both user and users for the two queries. We have a create user, update user, and lead user resolver function for those three mutations. And then we have also the resolvers for the user type, which, if they follow this very trivial pattern, you can actually omit because at least in JavaScript, the GraphQL JavaScript implementation is smart enough to infer these resolvers. And then you have the third part, the setup. So you first need what's called a GraphQL engine. And the GraphQL engine is the part in your GraphQL server that is responsible to invoke all the resolver functions for the fields that are contained in the query when it's coming in. So the GraphQL engine orchestrates the resolver invocations. Then you need a network layer. So if you build your GraphQL server with HTTP, then you can use some common like web framework. In the example that I'm going to show you later on, I'm going to use a GraphQL server library that is called GraphQL Yoga, and that is based on the Express framework. So if you have ever worked with Node and built like a web server with Node, it's likely that you've come across the Express framework, which is really popular in the Node space, and GraphQL Yoga is built on top of that. So basically, GraphQL combines the HTTP capabilities of Express with the GraphQL resolution from the GraphQL reference implementation in JavaScript. And then you have your middleware that you can integrate. So that's also where you would put any sorts of analytics, logging, crash reporting, all that kind of stuff. So let's put it all together and just use the simple hello world example. So imagine this to be a very simple Node script like the most simple GraphQL server that you could write in a single file. So here we define the schema. It's just a JavaScript string that spans across multiple lines. So we use the backtick notation. Then we have the resolvers object. So these two things we saw on the slides before. And then we're putting it together using the GraphQL server that we import from the GraphQL Yoga library. And then we start the server, and that's how we have our Hello World GraphQL server up and running. And if you want to learn more about this, I recommend you this blog article, GraphQL the Schema, which has a really thorough introduction to how the GraphQL schema actually works under the hood, and also touches on how the schema interacts with resolver functions, and then also a GraphQL server tutorial on how to GraphQL.com again. Which brings me to the second part of the demo, where I'm going to show you live how the GraphQL server that I just showed you in the previous demo actually is implemented under the hood. Oops, okay. And here is the implementation of the GraphQL server. So this was the GraphQL server as a reminder. We had these 4 operations, and here is now the implementation. And this GraphQL schema here, that defines these operations that we saw here in the playground in the API documentation. So, so this API documentation precisely is generated based on this GraphQL schema right here. We have one post query. We can actually also provide a search string. We can create a new draft, provide title and content of the new draft. We can publish a post, and we can delete a post. Here is the interesting part. So this is now the implementation in index.js. Here at the moment, I'm just using local post data for the things that are happening in my server, so I don't have any persistence layer set up at the moment. And I just have one post, and that was the post that we saw upon the initial query. And here is how it's implemented then. So the post query just returns the post data array if there is no search string provided. If there is a search string provided, then I filter for the title and the content of all the posts and only return those where the filter applies. Then the create draft mutation looks like this, that I'm creating a new JavaScript object that is called new post. I have this little helper here to increment my IDs. And then I pass the title and the content that is provided through the query. I can read it with this args argument here. And then by default set publish to false. So that's how we create new posts. Drafts, I put this draft into the post data array and then return it so that the caller who submitted the mutation also gets the data in return. The publish mutation also is fairly straightforward. So I'm looking for the post inside the post data array of which the ID was provided through the mutation. I set the publish field to true, return it. And delete post, also fairly straightforward. Just find the right post, delete it from the array, and return either the deleted or null if there was no such post. So I now restart the server, and remember, because all the data is local, if I restart it, then the post query just will show me the one post that I store locally in my post data array. And it would actually be nice if I had a query that would allow me to ask for a single post by its ID. So here I would like to do something like this. Title, content, and published. So instead of querying all the posts, I would want to query a single post. But at the moment, this won't work with the current GraphQL schema implementation because I don't have that post operation yet. So let's go ahead and implement it. The first thing that I need to do for that is actually tell my GraphQL schema or the GraphQL server that I want to have this new operation in my API. And that works simply by adding it to the GraphQL schema right here. So the exclamation mark which I set here is, means that this parameter is required. So the GraphQL server will reject any operations where the ID parameter is not provided. And then it returns a post object, and here I don't put an exclamation mark because it might be that the post with the provided ID actually does not exist in the backend. So in that case, we would return null. And for the implementation, it's also fairly straightforward. I just add this new resolver function that finds the right post inside the post data array by comparing the IDs. And that should be it. I'm restarting the server. I am reloading my schema, and I see that the post has been added to the auto-generated API documentation, and also these red squiggly lines have disappeared. So I should now be able to use that operation here as well. Let's try it. All right, it works. All right, so now you understand what the GraphQL schema definition looks like, how resolvers are being implemented. So let's now get to the next part, building GraphQL servers with Prisma. First, what is Prisma? So basically, Prisma is a strongly typed access layer for your database. Think of it somewhat as an ORM. So it tries to solve a similar problem, but it has a lot more features and it's also a lot more powerful than traditional ORMs. The way how you're using Prisma for your database is that there is a Prisma client that is auto-generated based on the data model that you provide. The data model, we'll talk about it later, will be mapped to your database, and it's also type safe. So one core goal of us that we have at Prisma is to basically enable what we understand as end-to-end type safety, so that your entire application should be based on a coherent set of types from the database to the front end. And GraphQL is what is making that possible. And then Prisma also has a declarative approach for actually modeling your data and for database migrations. And we'll see also what that looks like. How does Prisma work? So there are basically these 4 steps when you get started with Prisma. First, you have to connect your database. So you can either use a new one or you can use one that already has existing data. Then you would go and define your data model. If you already have some data in your data model, then Prisma will do introspection of your database and will actually also auto-generate that data model. But you define the data model for your application, then you migrate the database where Prisma takes a look at your data model and maps it to the underlying SQL database, or we actually also support Mongo, so it would also map it to basically the collections in Mongo. Next step is that you generate the Prisma client that allows you to actually talk to your database through that type-safe layer, and then you can go and start building whatever you want to build. To give a bit more context of where Prisma actually fits into your stack in the backend, I want to depict 2 GraphQL architectures that are quite common, but there's also a spectrum in between these 2. So these are 2 examples, basically, of how you could build your GraphQL application. So the first one is what you would call a GraphQL monolith. That's a very standard architecture which has these 3 very classic components that we know from like 3-tier architectures. We have the client, we have the server, and we have the database. And in this particular case, Prisma sits inside your GraphQL API server, the Prisma client, and basically connects your resolver functions to the database. So the entire goal of this is to simplify the implementation of your resolver functions so that you don't have to write SQL or like things like that inside your resolver functions and make the resolver functions really long and cumbersome. If you use Prisma, then the implementation of your resolvers will be fairly straightforward. And then the more complex one on the other side of the spectrum would be a microservices architecture with a GraphQL gateway. So actually, GraphQL is like really often also used as like this proxy technology that you put on top of existing systems, so that your front-end developers have this one coherent API that they can talk to, one single endpoint, and all the more complex orchestration of where the data is actually coming from which system, then is happening inside that gateway server. And here you can also use Prisma, where we actually also have a way that basically allows you to use Prisma as a standalone server on top of your database that you can deploy, for example, with Docker. And that standalone server basically provides a database service out of the box for your database, and then you can merge all of these services inside the GraphQL gateway. For the example that we're building, we are very much on the left side, so this is the architecture that I'm using in the live demo. Why GraphQL and Prisma are such a great fit? So first of all, with Prisma, you get really performant query resolution. With GraphQL on the server side, you often run into what's called the N+1 problem, which basically means that if you're requesting a particular user and then you want to have all the posts of a user, you first need to basically make a database request to get information about the user and all the post IDs, and then you need to make more database requests for each post of that user. And that's called the N+1 problem. And the Prisma client has a built-in way of basically alleviating that problem with batching and caching. Then with Prisma, you get CRUD and real-time operations for your database out of the box. So it's kind of similar functionality as you also get with Rethink DB, for example, where you can receive live updates about events in the database. Prisma offers that as well. And then again, the point about end-to-end type safety. So you can use Prisma also to build a REST API or some kind of other tool where you would maybe otherwise use a traditional object relational mapper. But this end-to-end type safety approach is something that you can really only get with GraphQL. And that's what we're trying to enable. And actually only last week we released a tool that is called GraphQL Gen. That is a code generation tool that looks at your GraphQL schema and scaffolds the resolver implementations that you need afterwards. And it also makes your resolvers entirely type safe. So if you're using TypeScript, if you're using Go, for example, the Prisma client is also available in Go, then this enables you to really have type-safe resolvers, so you don't run into any stupid errors at runtime again. And if you want to learn more about Prisma, you can check out the quick start in our documentation, or read the Prisma introduction also in our docs. Let's now get to the last part of the demo, where I want to show you how we can adjust the implementation of the current GraphQL server such that we actually store the data and in an actual persistence layer that I'm going to set up with Prisma. But first, I want to just show you a bit how Prisma works in a very simple node script. And for that, I'm going to create a new folder right here in my project. Go to demo 123. And initialize a new Prisma project in here using the Prisma CLI. So the Prisma CLI is a tool that you can install with Homebrew or with NPM, and it allows you, or it helps you with all the typical workflows that you have to do around Prisma. And here, it now asks me a couple of questions about how I want to set up Prisma for this new project. So I could either use an existing database, in which case Prisma would introspect the database and then generate the client API on top of that. I could go and start from scratch with a new database that would be configured with Docker in this case. But I want to use a hosted database in Prisma Cloud to make things really simple for this particular demo here. I'm just going to answer a couple of questions, and then I'll say that I want to use the JavaScript client since I'm using Node.js in this application. So let's see what the Prisma init command now generated for me. 3 files to be precise. We have the Prisma YAML, which is kind of the main configuration that is used for Prisma. It points to a data model, and that data model is what I was mentioning before when I was talking about declarative data modeling and migrations. So here by default, Prisma put in this user type, but for our application, what we actually need is a post type that looks similar to the one that we have defined in our GraphQL schema. And one thing you'll notice also is that we're using the GraphQL schema language also for the data model right here. In the future, we might open up the API that you can also use some other kind of schema language to define what your data model should look like. At the moment, we're using GraphQL SDL, and it's really suitable because it's super simple and intuitive. And at the same time, it's also really powerful, so it supports constructs like interfaces and unions as well, so you can really express a lot of things here. And because this is the data model that is going to be mapped to my database that is hosted in Prisma Cloud on the demo server, I can add some of these special directives right here that express certain constraints or extra functionality for what's supposed to happen with these types in my database. And in this case, I want every ID of every post to always be unique, and I want that every post that is not explicitly created as published to have a default value of false. To put that API into place, I need to run the Prisma deploy command, and then go ahead and generate my Prisma client. And now I can go ahead inside my node script and use that generated Prisma client to perform operations against my database. So here is the code that was generated for my Prisma client. And because we also put the TypeScript type definitions in here, I actually also get auto-completion for the operations on the Prisma client instance right here in my editor. I'll show you that in just a second. I first create this main function right here and call it so that we can do asynchronous operations. So let's start by just requesting all the posts that we currently have stored in the database. So I'll create a query on the Prisma client, and here my code editor suggests me all the different operations that I have available. So already at this point, you basically take advantage of this strongly typed layer for your database. Despite the fact that I'm using JavaScript, I still get auto-completion for the operations that I can use on the Prisma client, which I personally find pretty amazing. So here we go, we just ask for all the posts, and then we are going to print them to the console and see what happens. What do we expect at this point, actually? We expect an empty array. But before I actually run the script, we need to do what JavaScript developers love most, and that is adding new dependencies to the project. So I'm adding the Prisma client lib and GraphQL dependency, and now I'm actually able to run this script.
Probably want to log all posts?
Sorry?
You probably want to log all posts, I would think.
Ah, thank you. Thank you so much. So I'm doing live coding, and please, if you catch any of these kinds of issues, point them out. Thank you. All right, we see that an empty array is being printed exactly as we expected because the new database on Prisma Cloud actually has no data in it yet. So let's go ahead and change that by creating a new post using the create post function right here. Again, just providing random data, but always with auto-completion. And if I run this again, then we see that one post has been created. I can run it again. And we see that both posts are now part of the all posts here. Then I just quickly want to show one more thing. So here, this post field also allows me to provide a couple of filters for pagination or to just filter according to specific properties. So here, if I provide the where filter, I can see all the different ways how I can filter the posts. And I could, for example, do some filter for posts that contain this in their title, and then I expect that I just get the one that I created first back. All right, so far for the Prisma client. And now let's bring these two worlds together, the Prisma client and my resolver functions, to see how the Prisma client helps me to implement my resolvers. I'm deleting all the previous implementations because I don't need them anymore. This is gone. This goes away. This is not needed. And I'll start with just creating the queries actually. So I'll put comments on all mutations so that we can test everything step by step. So the way how I now implement the posts query right here is basically by just calling the post query on my Prisma client. But because we have this search string right here, so here I want to make sure that I'm able to filter for the right objects. I want to provide, this was of course a mistake here, so where, and then I actually have two conditions, either the title contains the search string or the content contains my search string. And for the post operation, it's also fairly straightforward. I simply use the post query that I have available here and pass the ID that is provided in the query. Let's test this. So I'm starting my GraphQL server. I'm going back here. And now we're back in the playground that I showed you in the very beginning, where this time, if I refresh this, because I commented out all the mutations, we just have the posts and post queries available at the moment. But if I now send the post query, I expect to see the two posts that I previously created in the script. So those two with the random content and the random title. There is a slight bug at the moment because I'm on the latest beta, is that sometimes mutations on the client are executed twice, but that's on the beta, so you can still feel safe about things that are going on in the client. All right, so the post query works. Let's actually see if we can also ask for a single post just by ID again. And there we go, this query also works. So let's go ahead and send the mutations. For the create draft mutation, we just use the create post mutation that was generated by Prisma. For the title, we provide the title. And for the content that were submitted through the query. And one quick side note, so if you're using TypeScript, then all of these resolver arguments right here and the return values will also be typed. So at the moment for me it's like a little bit hard because I need to make sure that I don't introduce any typos. If I were using TypeScript, then the compiler would catch all the issues that I introduce in my resolvers for me. For the publish mutation, we are using the update post operation that's provided by the Prisma client that take a where argument to describe or to specify which post should be updated, and then what data we want to update. So we want to set the published field to true. And finally, for delete, we have the delete post mutation, where we can also provide the ID of the post that is supposed to be deleted. Let's start the server. Oh, so now GraphQL complains because I only implemented the resolvers, and it's trying to match those resolvers against the GraphQL schema, but because currently there is no mutation, it complains. So I'm putting in the definition of the mutation, starting the server, refreshing the playground. I see that all my operations are back. I can go ahead and create a new draft, again with random data. So this probably again was created, yeah, it was created twice. So let's use the delete post mutation to get rid of one of those. And let's see, now we should only have one RRR post left. That's the case. All right, that's the demo, how you can build your GraphQL server with Prisma. Before I let you go, I quickly want to add that we care a lot about the GraphQL community, and we are hosting the GraphQL Conf next year here in Berlin. So we rebranded what was formerly actually called the GraphQL Europe Conference. This year we had around 500 attendees. Last year there were 300 attendees. We had speakers from GitHub, from Facebook, from Twitter, from Shopify, from Yelp, so really high-profile companies that are using GraphQL in production today. We actually also had the GraphQL co-creators speak at the event. So I can only recommend, if you're interested in GraphQL and how you can introduce it in your company, that you get your tickets for GraphQL Conf next year. And that's all I have. Thank you so much.